After properly completing the dilutions of your copper sulfate pentahydrate, you will need to transfer a sufficient amount of each dilution into the cuvette in preparation for use of the spectrophotometer.
Gently wipe the two sides of the cuvette where the light will pass through.
The first cuvette you will need to put into the spectrophotometer will contain just water. This will allow you to zero out the machine before actually scanning your solution.
Failing to zero out the spectrophotometer with a blank will cause all of your absorbance values to be off because of the error in the calibration.
Begin by scanning your stock solutions across all wavelengths.
The spectrophotometer will produce a graph that will show you the absorbance of your solution of various wavelengths. You will need to determine the wavelength at which the absorbance has its highest peak. This is your lambda max.
You will use this wavelength to measure the absorbance of the stock solution along with each dilution. In order to do this, you will need to change the wavelength in the setup of the spectrophotometer. Our lambda max was 600 nanometers.
Now you are ready to re-enter your stock solution to measure its absorbance.
After clicking Read, the spectrophotometer will display the absorbance value on the computer screen. Record this in your notebook.
You will need to perform each of these steps with every dilution, being sure to wipe the sides of the cuvette and close the spectrophotometer door each time. Record your results.
Once you have recorded the absorbance of all your dilutions, use the spectrophotometer to figure out the absorbance of your unknown solution.
The spectrophotometer will record all the absorbance values in the order in which you read them.
The recorded absorbance values and calculated concentrations will allow you to determine the relationship between absorbance and concentration, and allow you to calculate the concentration of the unknown.
The absorbance of a solution can be determined through the relationship between concentration and molar absorbance using the Beer-Lambert law.